Now, people did something that I wish they wouldn't do until they've done something else. Most people then did something that's, and I said it in class, this is partially good and partially bad. Okay? Most people shaded in this region here, this little narrow region here, and this little narrow region here, between 0 and whatever the performance level was for the person. That's okay, because when you look up your Z table, that's the region your Z table is going to give you. That's, you know, your Z table is going to tell you what part of the total area is in that thin region. So it's good that you drew that region, it's good that you know that. But if you did that before you made an estimate, I think you put the cart before the horse. It doesn't really hurt, as long as you make the estimate before you ever look at your Z table. Now, what is it we're trying to estimate? We're trying to estimate who did better. Okay? Well, better than what? Better relative to the other people. So here's our performance. Now, in what direction is better? Well, better is in this direction, right? So everybody over here, represented by this part of the curve, did better than this person. This person did better than all of these people. Okay? So we want to actually estimate this area to see how many people this person did better than. The person that did better than more people has at least some kind of bragging rights. So we draw this region and we estimate it. Okay, now I didn't draw my estimate on here, but I made people put the word estimate in their estimate. Okay? And if I'd have estimated this, well, I know the curves pretty well, so I'd estimated 70%, but let's just say somebody estimated 80%. Not an unreasonable estimate, because not everybody draws a really good curve and not everybody's good at doing estimates. Now, if they estimated 30%, that would be really bad, because, of course, 50% of the curve lies from the middle over, and you still got more of it here, right? And that more of it happens to be what the Z table is going to tell you in a minute. But you know, if you estimate under 50% when you have this picture, you're not understanding areas. Okay? But everybody's doing pretty well with estimates when they actually do the estimates. So one thing I'm emphasizing is I want these estimates as part of your process before you ever look at a Z table. And preferably before you even draw this region, but yeah, that's no big deal. I can't tell what you drew first anyway, so you can get away with anything. Okay, over here, you might have estimated, if you're the person that estimated 80%, your estimate here might well be 70%. Those are not unreasonable estimates, okay? One of them's a little high, one of them's a little low, but they're not that unreasonable. Okay, now of course I've got the actual figures here, but we've got to talk about where they came from. We haven't quite gotten there yet. So what I'm saying is, this is the area that corresponds to the people that this runner beat. And this is the area that corresponds to the people that this runner beat, the same information. And we can see clearly that since this point is closer to the middle than this one, that this area is going to be a little bigger than this area, but it's not going to be that much bigger. So we want to see how much bigger it is, because of course whoever is on the losing end of this argument, which will be this person, can still argue that difference doesn't count. That difference is within statistical deviation. You can't say anything about that. Okay. So I made a note here. Shade and estimate this area before you look up the Z table. Before you look at the Z table. Because I guess you got to look up the Z table before you look at it. Also, one comment before we go on with this, because the rest is pretty simple. Some people didn't stop to think, and people that do very well, okay, people that do extremely well with this. Some people didn't stop to think that better is in this direction, because you're used to bigger being in this direction, which it is, but a bigger time is not better when you're in a race, okay? So I think we all understand that. So you got to be sure you know which way is better. And then do a sensible shading that gives you the information that allows you to answer the question, whatever that question has to be. Okay, well, now what do you do next? After you've done your estimates, and not until. Okay, now why do I want you to do the estimates? Two reasons. One is, every time you do an estimate, you have to think about the curve, and it reinforces your picture of the curve and what the curve is telling you. Okay. The other is that it's a hedge against mistakes that you might make when you start doing your calculations. You know, you're probably going to some extent rely on some formulas, although it's not really necessary, and I advocate that you do this without using formulas, and then use the formulas to reinforce both the formulas and what you did. But you've got a formula for calculating the z value here, okay? That would work if you had numbers that you couldn't immediately see, or that would work even if you don't quite understand why this is 1/3. There's a formula for this. I recommend that you think it before you use a formula. You think it, get the answer you think you're going to get, and then compare with the formula until the results of the formula are agreeing with what you thought. Then you're both thinking right and you're using the formula correctly. Yeah, there are alternatives to that, but almost certainly that's going to be the outcome. Okay, so for two reasons then. One, because it keeps reinforcing what you're doing, gives you a picture in which you can fit your understanding of the problem, and then it's a hedge against subtracting maybe where you should add, okay, or something worse. There are plenty of things you can do after you look up the z value that are going to be wrong. If you have the picture and you have your estimate, you're probably not going to end up making that mistake. You might make it in the process, but you're going to stop and think, why is my result here so much different than what I know the picture tells me? And you'll figure it out. Okay. Now, we look up the areas. Okay, and I didn't write the areas on the screen because everybody had them in their paper, but, okay, I'm going to kind of make this one purple. This turns out to be about 20%. I think it was 19.1%, but let's just call it 20% from the table. In the area here, I think it was about 13%. And that 20% is actually, I think it's 19.1%. So actually, since that's what I used here, I'm going to change that. I'm going to call that 19. Some people rounded to 20, and yeah, I'm kind of okay with that. Okay. Excuse me. Okay, this is 19%, and the purple area here that I didn't make purple is 13%. And in both cases, what you have from the middle over is another 50%. So from your picture, it's obvious what you do with the 13% and the 50%. To get all of this, you add this little bit to this. You get 63%. And up here, you do the same thing. You add the 50% to the 19%, you get 69%. Okay. So we conclude that the first runner appears to have beaten 69% of the 12 people in the race, because we stated that now, if there are 12 people in each race, how many did each person beat? Okay, so we're answering that question. Multiply the 0.69 by the 12. I think you get 8.3. I think it's 8.28. And here, I think you get 7.56, but check my arithmetic. So this person beat 8.3 people. This person beat 7.56 people. Now, if I'm this person, and say, yeah, I beat more people than you did. Well, no, if you round this off, he beat 8 people. And if you round this off, he beat 8 people. Okay? So you can come back with that. And then this guy can say, yeah, but you know, the difference between my mean and your mean is almost 1. Okay, it's a difference here. It's what? It's like 0.74. Okay? That's 3/4 of a person. So chances are he was 1 person ahead if he wants to argue it that way. And there are ways to resolve that argument, but we're not going to go that deep into it. And I'm sure you're glad of that. Okay? So there is your argument. And there's what you can determine by statistics. And the last thing we determine is nobody really wins this argument, but it's a friendly argument, and they're going to continue ragging each other until they get tired of it. That's what guys do. Okay. Now, I could have had 2 girls in the race, but anything I said about the way they argue would be regarded as sexist. So I'm not being sexist by choosing guys. I'm avoiding being sexist by talking about the way girls would talk about it, because I don't know how that goes. I don't have direct experience of that. So I'm kind of sticking with what I know here. Okay, well, there it is.